Meteorologist Alexander Williams here with you. I'm going to be starting a new digital piece called Weather Word of the Week, and it's going to deal with weather terms. So you'll be learning more about the weather, but it'll deal with a term that affects the weather that week. This week, we've seen lots of MCSs. We've said it again and again and again in complex of thunderstorms. And so I'm going to break down today what exactly an MCS is. Well, it's just a large cluster of thunderstorms. Here's a satellite image. This is actually the state of Texas. You can see how big these complex of thunderstorms can get and how high the clouds can get. These are cooler temperatures, and the cooler they are, the higher up in the atmosphere they are. And so those are some very tall thunderstorms that are billowing out from that complex of thunderstorms, created severe thunderstorm warnings, flash flood warnings, and it can be quite a headache. We see a lot of them here across northwest Arkansas because of our positioning to the Great Plains. Well, what does MCS stand for? Mesoscale convective system, and this is the textbook definition. If you want to pause the video and read it, you can go ahead. If you're like me and like, well, what's the simple definition? Here's the simple definition. It's just a system of thunderstorms that produces rain that stretches over 60 miles in one direction. So you saw how big the complex of thunderstorms were. That takes up most of the state of Texas, and these can get very, very large. Well, how do they form? Just like any thunderstorm, you got rising currents of warm air. As the warm air rises, it condenses, forms clouds, and then cooler air starts to sink down the base of the storm. That creates what we call in meteorology a cold pool, and it acts as a cold front. And as it slides out from the bottom of the storm, it acts as a cold front, lifting up warm, moist air ahead of it. That creates more thunderstorms, and the process continues and continues and continues. And as long as there's warm, moist air out ahead of these storms, they can go on for hours. In fact, that's actually what the mesoscale definition means. It means the size of a thunderstorm and the span of about a couple hours. So there's three major impacts that you can expect when you hear an MCS is headed our way. One is flooding. It could be a possibility that these systems stall out, and a lot of times they do. If the upper level winds stop supporting them, then they can stall out and drop tremendous amounts of rain for several hours. That can cause flash flood warnings and flooding in some places, but it also brings beneficial rain for the Great Plains. In fact, if we didn't have some of these systems, we would lose a lot of our crops across the Great Plains because they need this rain through the summer months. And so the MCS is able to deliver that type of rainfall that is needed for the Great Plains. Damaging wind, that is the second thing. These can produce severe thunderstorm wind gusts of at least 58 miles an hour or more. In fact, they can produce winds up to 80 miles an hour and over 80 miles an hour. You're getting close to EF0 to EF1 tornado strength there. So very strong straight line winds. And these storms can stretch 250 miles and produce damaging wind along that, even up to 75 mile an hour peak gusts every couple of 100 miles or spaced out or so. Well, that's called a derecho. And we see those across northwest Arkansas and the River Valley because of our positioning to the Great Plains. So we'll see derechos. We'll see maybe if we see some this summer, but we'll definitely see a lot more MCS activity. And then a third and final thing to remember is it produces a tremendous amount of lightning, and that is because convection, which is rising and sinking air, creates a lot of static electricity in the clouds. And so these are highly electrified storms. You'll see lots of lightning with these storms as they come racing towards us. Typically they fall apart as they get into northwest Arkansas. As you know, the Fayetteville fizzle. Well, I hope you learned a little bit about mesoscale convective systems this week. Look for more content from me and learn more about the weather as we go through the summer.